All right, so I've got a example function for us to take derivatives of. So go ahead and take the first derivative. Try to keep everything in nice neat columns so it's easy to track where terms are coming from in your work. And then take the derivative of that for the second derivative. And then take the derivative of that for the third derivative and see if we see any patterns. So go ahead and pause. Okay, welcome back from pausing. So f prime, derivative of x to the fourth is 4x cubed. And then the divide by 24 is just a constant multiplier of 1/24. I could write it as a 1 over 24 out front, but I could also just keep writing it as divide by 24. And then 7 times sine of x. The 7 is a constant vertical multiplier, so I'll keep the 7 there. Derivative of sine is cosine. So that's the first derivative. The second derivative, so if this was position, this would be velocity. Then acceleration, so you should pause the video at this point if you haven't taken the next derivative yet, and then unpause. So the power rule on 4x cubed, the 4 is going to stay there. The x cubed is going to come, the 3 is going to come down in front and give me 3x squared, and still got my constant factor there. Plus 7, and then derivative of cosine is negative sine. And you're right, I tried to trick you. I need a multiplier there to keep me from doing a subtraction. And then go ahead and do the next derivative. Okay, so f triple prime would be 4 times 3 times 2. X squared derivative is 2x divided by 24. And then what's the derivative of 7 times negative sine? It's 7 times negative, and what's the derivative of sine is cosine. Okay, and then what's the next derivative? Here's where we usually drop into like super 4 notation. It'd be 4 times 3 times 2. What's the derivative of x? Derivative of x is 1 divided by 24 plus 7 times, what's the derivative of negative cosine? Well, I can keep the negative there because it's just times negative 1. And then what's the derivative of cosine? It's negative sine. And this is one of those rare occasions where I'm okay with us simplifying a bit. So this would be plus 7 times just plain sine. So we got sine back after 4 derivatives. And then what do we get here? Well, what is 4 times 3 times 2 times 1? 1 times 2 is 2, 1 times 2 times 3 is 6, and 6 times 4 is 24. So this all boiled down to just 1. Kind of interesting. You might have noticed I didn't do any arithmetic as we went along because the pattern 4 times 3 times 2 times 1 is kind of important. You might have seen factorials before. I'm essentially getting a factorial there. Not to spoil all of Calc 2 for you. It's not really all of Calc 2. Let's try the fifth derivative here. What's the derivative of 1? Well, 1 is a constant. How much does it change when x changes? It changes 0. So the derivative of 0. And then derivative of 7 sine, I copy the constant multiplier. Derivative of sine is cosine. So I started with a power or polynomial kind of term here. And after I took enough derivatives, I just got a 0. What's going to happen if I take the sixth derivative? What's the derivative of 0? How much does 0 change when x changes? Or how fast does 0 change? It changes 0. And then I'm going to have 7 times, what's the derivative of cosine? Negative sine. So can we say that taking derivatives, higher and higher derivatives, makes terms go away? Well, that's a puzzle I'm just going to leave you pondering for now. All right, that wraps up chapter 6.3.